So let me erase this, and then later we can have item 2. All right, so item 2. Item 2, in fact, this one. Item 2, first of all, this one. Sample mean. All right, so this one, which property we should apply? Sample mean. Sample mean. Or maybe you can have these. In fact, normal, right? All normal, sum of normal should be normal, right? And sum of normal should be normal. So normal again. And actually you can find that property. In fact, this one should be mean again, right? But finally, balance should be this. In fact, this is result checked by results in chapter 4. However, we can follow property. Sum of normal should be normal. As for the parameter, that's okay. Find mean and find variance. And I try to find balance. First of all, balance should be sum of individual variance. Individual variance for this. Should be this. Is it okay? Oh, sorry, not this. Right? And the formal sum should be sum of all values, so it should be this result. You can apply the result derived in chapter 4, or maybe you can use the current result, and so they can know it should be this. Is okay? So finally, we can claim X bar follow this. No problem, right? Maybe this one, I call it 2.1 and 2.2. And this one, in fact, we can have for this. Is it okay? The original W1 follow the form I rewrite. And so that variable is sample mean minus mean over square root of this. And in fact, it's normal with the mean and variance here. So if so, follow this, still follow linear transformation. So linear transformation, so it should be this. Standard normal is okay. The inner side is still normal and follow standard normal. Standard normal rests out to 2. And what is the distribution? Chi-square, right? It's gamma and gamma. It's chi-square. Degree of freedom of 1. Right? So that's why we have item 2. about item 2, check it. So we're okay, right? And talk to your members. And Darwin, okay, right? And talk to your members. And Alice, okay? So talk to your members. Beth, Sam, talk to your members. So after now, we can apply the results in the previous, using the facts previously discussed. Or maybe you can refer to some result in our discussion of chapter 4. Sure, let me move on. For the remaining, maybe I don't go through all the details because of limited time. I just let you know. In the following, we may jump here. I think you can check it. And this one, we can use supplement 3. So by utilizing supplement 3 and also use some changes. And we just want to tell you if we have the given variable sample mean, and second one minus sample mean, second to nth one minus sample mean. These random variable, all the steps here just want to prove, they are independent. And if they are independent, then we can know W sub 1 and W sub 2 are independent. So for the steps here, I think I skip, I using supplement 3, we can have the proof to reach W sub 1 and W sub 2 are independent. Alright, for this one, I totally skip because no time to check it. Or otherwise, we cannot reach, for example, chapter 8. And if so, actually, you can prove it as well. We know W actually equal to this. W actually equal to W2 plus W1. And W here, we prove it, it's chi-square, degree of freedom n. And this one is chi-square, degree of freedom 1. Chi-square actually it's gamma. And it's gamma. So this one, if W2 and W1 are independent, only chi-square with the degree of freedom n minus 1, or otherwise we cannot reach chi-square of degree of freedom of n for W. So this way, we use this way to prove W sub 2 should be chi-square with the degree of freedom n minus 1. And that's it. So this time I skip some details, you can check it. So finally, yes, we can use this one, but we need to have the lengthy procedure so that we can reach the proof for this one. So finally, we have this result. Yes. And take a picture for this because later you might use. I skip some detail to prove it, but at least I really feel some important steps.